Okay, so looking at this problem here, we can begin by modeling the situation. So we know that she's going to go 15 across this ways, and then boom, boom, and that's her whole trip, which is 36. So that gives us the following equation. So we know that 15 plus A plus B is going to give us the entire trip, which is 36. Now we can subtract 15 from 36. So we have this equation here. We'll come back to that. Let's go place somewhere else. Looking at this diagram, we do have a right triangle because it was a rectangle in the directions. So because that's the case, we can use Pythagorean Theorem. So the hypotenuse should always be by itself in your setup. So go this one squared plus this one squared equals that one squared. We can turn this into 225. So now here is the key part. We have two variables, A and B, and so we have two different equations. Generally speaking, what you want to do is take the easier equation, the one that looks simpler, and get either of the letters alone. Let's suppose that you wanted to get B by itself. So let's take the A and let's move it to that side. So that it would be B equals 21 take away A. And then what we can do is we can take this bubble, which equals B, and plug it into the B in the other equation down here. So let's grab this bubble and let's drag and drop it in right there. And so now we have this thingy-majig, which is going to be squared. So let's write this twice. And now from here, why don't we do one of these ones and let's see what we get. And then we have A squared, and A squared is 2A squared, and that's negative 42A. And I saw a lot of students get to this point. And then because this is a quadratic, we're probably going to hit this with a quadratic formula, meaning that you want this to be 0. So let's move this number there by subtracting 225 from the 441. So you see, now we can actually go quadratic formula if we wanted to, but I noticed that all of these can be reduced by 2, and so we shall. And now we can go quadratic formula with ABC, where this 1 plays the role of A, and this negative 21 is B, and that 108 is C. So let's see what quadratic formula gives us. And so quadratic formula gives us here, this double negative is positive, that in a calculator is 9, the square root of 9 is just 3. And so now we have two separate cases, so let's break these up into two cases. So here's what quadratic formula gave us. We got 12 and 9, but 12 and 9 represent the value of whom? Well, quadratic formula was applied to this equation. In this equation, the variable being used was A, which represents this here. So the question is A 9 or is A 12? Well, let's see. Let's pretend that A is 9. If A is 9, then what would be B? We can take 9 for A and plug it in there. If you take 9 for A there and subtract, then B would be 12. If you pretend that A is 12, plug it in there and subtract, then B is 9. So the point is, the dimensions are 9 and 12 regardless of who you call which. So generally speaking, the length is longer. So what we can say is that it's 12 for the length, and we can say it's 9 for the width. So the dimensions would be 9 by 12, and I think it was meters. So it's like 9 meters by 12 meters.